Part 5. Practice Test. Number 18. An amphitheater charges $75 for each set in Section A, $55 for each seat in Section B, and $30 for each seat in Section C. There are 3 times as many seats in Section B than in Section A. The revenue from selling all 23,000 seats is $870,000. If A represents Section A, B represents Section B, and C represents Section C, write a system of equations that represent the situation. So for this one, we know that the total amount of money was $870,000. So we can write that as part of our system. So we have $870,000, and it's for the seats from Section A, Section B, and Section C. So again, Section A was $75 per seat, so we'll just call that 75A. Section B was $55 per seat, and then Section C is $30 per seat. So that would be our equation for that one. For our other equation, we want to find the total number of seats. So for that, we just add A, B, and C together to get the 23,000 seats. So we have our 2 equations, number of seats and money. Number 19. Use substitution to prove -5, 6, 1 is the solution to the system of equations. So the first thing we'll do is label each of our equations. E1, E2, and E3. From there, we're going to want to solve for a variable and substitute into another equation. So we'll start with E2 since it only has 2 variables. We'll solve for Z. So we write down equation 2, and then we're going to solve for Z. Let's add the Z to the other side. We have 5y equals -31 plus Z. Add 31 to both sides. So now we have 5y plus 31 equals Z. We'll plug that into equation 1 to solve for y. So when we plugged in Z into equation 1, we get 2x minus 2y plus 5y plus 31 equals 3. And then from there we're going to solve for y. First you want to combine like terms. And we get 2x plus 3y plus 31 equals 3. From there we want to subtract 31 for both sides. So we have 2x plus 3y equals -28. Subtract the 2x onto both sides, each expression, you get 3y equals negative 2x minus 28. Divide each term by 3, and then we have y by itself. So from there, you want to plug in the y, plug in the z for equation 3, and solve for x. So when we plug in the z and we plug in the y, so let's plug in the z first. We have x plus 3y plus 2 parentheses 5y plus 31 close parentheses equals negative 21. And now we'll substitute y's in. So we have x plus 3 parentheses plus 2 parentheses 5 parentheses close parentheses plus 31 close parentheses equals negative 21. In those parentheses we'll insert the y expression like that. So from there we're going to solve for x. So these 3's cancel out, and then we have x plus, or x minus 2x minus 28 plus 10 parentheses negative 2x minus 28 all over 3 plus 62 equals negative 21. From there, we could go ahead and distribute that 10 into each of these terms. And then we get this equation. From there, you want to combine like terms. So we have negative 3x so we combine like terms, we get negative x minus 28 so you get negative x plus 34 minus 20x minus 280 over 3 equals negative 21. From there we can subtract 34 from each expression, both sides. We get negative 55 equals negative x minus 20x minus 280 all over 3. To get rid of this fraction, we can multiply everything by 3. And then we get negative 3x minus 20x minus 280 equals negative 165. Combine like terms. And then we get negative 23x minus 280 equals negative 165. Add 280 to both sides, each expression of the equation. And then we get negative 23x equals positive 115. Divide each term by negative 23. And then you get x equals negative 5. And negative 5 is what we're looking for here, so we're done with that one. We could go on to find y and z. So we'll plug in our x into this equation right here to solve for y. So we plugged in our x and we're going to solve for y. Distribute. We get negative 5 plus 3y plus 10y plus 62 equals negative 21. Combine like terms. You get 13y plus 57 equals negative 21. Subtract 57 from each expression. And you get 13y equals negative 78. Divide each term by 13. Y equals negative 6. And that's what we should have had right here. We'll plug in both x and y to get z. We could just use equation 2. So we have 5 times negative 6 minus z equals negative 31. Distribute, you have negative 30 minus z equals negative 31. Add 31 to both sides. No, add 30 to both. Yeah, add 31 to both sides. So we get 1 minus z equals 0. Add z. Add z. And then you get z equals 1. And so that shows that this is the solution. Number 20. You're buying movie passes and gift cards as prizes for an event. You need at least 5 movie passes and at least 2 gift cards. A movie pass costs $6 and a gift card costs $10. The most you can spend is $70. Write a system of linear inequalities that represents this situation. So we could call movie passes M, and we could call gift cards G. So it says at least 5 movie passes. So that means greater than or equal to 5. And it's movie passes. So movie passes has to be greater than or equal to 5. So that would be our first inequality. It says at least 2 gift cards, so we'll say greater than equal to 2. And we're talking about gift cards. So that would be the second inequality. G is greater than equal to 2. A movie pass costs $6, so it'd be 6 times M. And means plus. Gift card is $10, so it'd be 10G. The most you can spend is $70, so that means less than or equal to. So your third inequality would be 6M plus 10G is less than or equal to $70. So this would be your system of inequalities that would represent the situation. Number 21. Write a system of inequalities to represent the graph. So we want to find these two equations. Let's go ahead and find the solid line first. We want to find 2 points, 2 lattice points. So we have 3, 0, and we have, or not 3, 0, 6, 0, because it's going by 2's. And then we have 10, -2. So we'll find the slope of these. It's going to rise 2 and run 4. So it's up 2, left 4. That's a negative slope. Our slope is -1/2. So then we have y minus 0 is something to the slope -1/2. We'll just say equals for right now. 1/2 x minus 6, because we're just using this point right here. Distribute and combine the like terms. We have y is something to -1/2 x plus 3. 0, 0 would be in the shaded region, so we'll figure that out based on 0, 0. 0 is what to 3? 0 is less than 3. So we'll put the less there, equal to sign right here. So that's one of your inequalities. To find your other inequality, you'll do the same thing. So we'll find the 2 lattice points. And our b in this case is 2. So it goes up 2, 4, 4, and then over 2. So our slope is -2. And then so we have y something -2x plus 2. Now plug in that 0, 0 again. It should be false this time, since this is shaded on the other side. So 0 is not something to 2. 0 is not greater than 2. So we'll put the greater than sign right here. So that would be your two inequalities.
Number 22. Use Gaussian elimination to prove that the solution is 4, 3, negative 2 to the system of equations below. First, we want to name each equation. E1, E2, and E3. So from there, we want to use, let's use E1 and E2 to find E4. So E1 and E2, and that's going to equal E4. Now let's go ahead and eliminate Y first. So to eliminate Y, we'll multiply E1 by negative 3, and let's multiply E2 by 1. So from there, we'll show those steps. We'll have negative 3, parentheses, the first equation, 4x plus 1y plus 6z equals 7. And then we'll do the second equation, just 1 times the second equation. So from there, we're going to rewrite it. So we have negative 12x minus 3y minus 18z equals negative 21. And then we have 3x plus 3y plus 2z equals 17. Combine the two equations together to get equation 4. So we get negative 9x, the 3y's eliminate, and then we have minus 16z equals negative 4, and that's E4. To get equation 5, let's go ahead and use equation 1 and equation 3. So to get rid of y, we'll multiply the first equation by 2 and the second equation by 1. So we're going to go ahead and write that right here. We have 2 times the first equation, and then 1 times the third equation. So from there, we can distribute. So we have 8x plus 2y plus 12z equals 14, and negative 2x minus 2y plus 2z equals negative 18. And then you'll go ahead and combine these. You have 6x, the y's are eliminated, plus 14z equals negative 4. And that is equation 5. So we have our two new equations, and we'll just use our Algebra 1 steps to eliminate to solve for the last variable. Let's go ahead and eliminate x for this one. So to eliminate x, we want the x's to cancel out. So we'll take E4 plus E5 that's going to equal E6. So to get the x's to cancel, we'll multiply the first equation, equation 4, by 2, and we'll multiply the second equation, equation 5, by 3. Because 2 times negative 9 is negative 18, 3 times 6 is 18. The 18x's cancel. So we'll go ahead and write that right here. 2 parentheses, negative 9x minus 16z equals negative 4, and 3 parentheses, 6x plus 14z equals negative 4. So we'll go ahead and multiply those out. Distribute, you have negative 18x minus 32z equals negative 8. And then you have positive 18x plus 42z equals negative 12. So from there you're going to combine the two rows together. So the 18x's cancel, they eliminate, and then you're left with 10z equals negative 20. From there, divide each term by 10. You get z equals negative 2. So that's what we want. To get the other two values, we'll substitute z back in to one of these equations to solve for x. So we'll just substitute z equals negative 2 into equation 4. It doesn't matter if you put it in equation 4 or equation 5. So we'll solve for x. Distribute, we have negative 9x plus 32 equals negative 4. From there, we'll subtract 32 from both sides. We have negative 9x equals negative 36. Divide each term by negative 9. And we get x equals 4. And that's also what we want here. Okay, the last one we want to do is substitute z equals negative 2 and x equals 4 into one of the original equations. Let's just do equation 1. Because the y is already, it's already by itself here. So we have 4 times 4 plus y plus 6 times negative 2 equals 7. Distribute, combine like terms. We have 16 plus y minus 12 equals 7. So then we have 4 plus y equals 7. Subtract 4 from both sides. And they get y equals 3. And that's what we wanted here. So that's solving the system using elimination. Number 23. Rearrange the equations to put them in standard form ax plus by plus cz equals d. Then write the system as an augmented matrix. So we want to have it in this form. Notice that the y is not on the right side. We want to change that. So our first equation will now be 6x minus 9y plus 2z equals 4. Our next equation, we want to move the x and the z over. So we have 2x plus 2y minus 3z equals 5. And then the last equation, we want to move the z over and the 4y over. We have a z on both sides. If we subtract 1z from both sides, we have 7z left over on the left side. So we have 7x minus 4y plus 7z equals 6. Okay, now they're all lined up and they're in order. So now you're ready to make this into a matrix. So to do that, we'll just take the coefficients and not put the variables. So we have 6, negative 9, 2, 4, and we go to the next row. 2, 2, negative 3, 5. And then the last row. 7, negative 4, 7, 6. And this would be our matrix. If you're drawing it, you could also write it like this. Number 24. Use Desmos to graph the system of inequalities. So you will go to desmos.com/calculator. So once you go here, you will type out your two inequalities. We have 2x plus 3y is greater than 4. Go down. 6y, and then to get the less than or equal to sign, first type less than, then type equal. And then x plus 2. So this would be the graph. And if you are doing it on a computer, you could just take a screenshot and paste it to your review. If not, sketch a picture and only shade in the purple part. So we'll just paste this in here. And that's it for the system. This intersection would not be a solution because we have a dashed line. Number 25. Use Desmos to identify the feasible region for the system of inequalities. Graph the inequalities and shade only the feasible region. It's the purple part. So you go back to desmos.com/calculator and graph the system. So we have 2x minus 3y is greater than negative 6. Go down. 5x minus 3y is less than 3. Go down, and then x plus 2y is greater than negative 3. Now, the feasible region would only be this triangle right here. With these vertices. So we could take a screenshot of this. and then put it on our page. So the green triangle part is the feasible region. Number 26. Solve the absolute value of 2x plus 6 equals 4x. Identify the real and extraneous solutions. So you have a positive part and a negative part. So for the positive part, we just take off the absolute value sign. And then for the negative part, we'll do 2x plus 6, and then we'll change one of the sides to negative, so we'll do negative 4x. Solve for x for both of these. Subtract 2x, subtract 2x, equals 2x. Divide each term by 2. X equals 3. And then we'll do this one. Minus 2x, minus 2x. 6 equals negative 6x. Divide by negative 6 each term. Negative 1 equals x. Now we're not done here. We want to plug it back into the original with the absolute value sign to see if it's real or extraneous. So we'll do that with x equals 3 first. So we'll have 2 parentheses 3 plus 6. And is that equal to 4 times 3? We have the absolute value of 12. Does that equal 12? Yes, it's true. So that means that x equals 3 is a real solution. Now let's see about the other solution here. So we'll plug in negative 1. So we have 2 times negative 1 plus 6 is equal to 4 times negative 1. We have the absolute value of 4 is equal to negative 4. An absolute value cannot equal a negative, so it's false. So it's extraneous. So we have one real solution and one extraneous solution. It's not always like that. You could have 2 reals, you could have 2 extraneous, or you could have one of each. Check your answers to make sure each time. Number 27. Describe the effects of f of x equals absolute value of x when it is replaced by negative 1/2 f of 3x minus 4 plus 2. So first we want to rewrite this so that you can have the horizontal dilation outside of the horizontal shift. So we have x and then minus 4/3. And then plus 2. So we got 4/3 because we divide each of these terms by 3 to factor it out. So this separated the front, this negative sign, that means it reflects across the x-axis. Now for the next part, the 1/2, it's on the outside, so it's vertical. it's a vertical shrink, a vertical compression. And then this 3 right here is a horizontal compression. This minus 4/3 right here means that it goes to the right 1/4, or 4/3. And then the plus 2 on the outside is a vertical shift going up 2. So if you were to write this as a sentence, it would look like this. So it says, the graph reflected vertically across the x-axis. It was vertically compressed by a factor of 1/2. There was a horizontal compression by a factor of 1/3. It horizontally shifted to the right by 4/3 units, and it vertically shifted up 2 units. Number 28. The solution for this graph is -5 is less than or equal to x less than or equal to 3. Write an absolute value inequality for the graph in the form absolute value of x minus b equals t. So b represents the midpoint and t represents the tolerance. So to get the midpoint, we'll take the 2 endpoints together and divide by 2. So 3 plus -5 divided by 2. That's equal to -2 over 2. That equals -1. So your b equals -1. So we'll say this is our b. Our tolerance is the distance between b and the endpoint. So we'll just take our endpoint 3 and subtract -1. That makes a plus. This is 4. So our t is 4. So our equation would be absolute value of x minus -1, which would be plus 1, equals 4. Number 29. List the axis of symmetry, domain, range, and vertex of the given graph. So the domain is left, right, x. It goes to the left forever. It goes to the right forever. If it just has lines going off the page, you can assume that they're arrows. That's all real numbers. And in interval notation, you would have negative infinity to positive infinity. The vertex is that sharp point where it changes directions. It's going by 2s, -2, -4, -6, -6, comma, -2. And the axis of symmetry is that dashed line that goes through the vertex. And that would be at x equals -6. And then for the range, it's going to be y is greater than or equal to -2. You could also put it in interval notation as bracket -2, comma, infinity.